Um, okay, this is the notes from 4-2. That is chapter 6.2 in your textbook. We're going to look at transforming and combining random variables. So we're going to describe the effects of transforming a random variable by adding or subtracting a constant and multiplying or dividing by a constant, basically mx plus b. Find the mean and standard deviation of the sum or difference of the independent random variables, and then find the probabilities involving the sum or difference of the independent normal random variables. We learned how to do the mean and standard deviation of the random variable, and we know that there's, from Algebra 1, you know that there's effects of linear transformations on shape, center, and the spread of distribution data. That does not change the shape. Adding or subtracting a constant A to an observation does not change the shape or measures the spread. Multiplying by B can change the multiplies, divides the measures of the center by the location of B, multiplies or divides the measure of the spread by the absolute value of D. B does not change the shape of the distribution. So we have an example of a probability distribution. So this histogram is showing the probabilities. So this would be a relative frequency distribution. Basically, it's the probability of you have your x's 2, 3, 4, 5, 6, probability of 0.15, 0.25, 0.35, etc. The mean is 3.75, which is found by x times p of x, and find the sum. And then the standard deviation is the square root of x minus the mean squared times the p of x, and then find the sum. Pete charges $150 per person. The random variable C describes the amount he charges, so 300 times 2, he still has the same probability. 300 times 3, still the same probability. The mean is now 562.50, and the standard deviation is 163.50. Because the x is changed, the mean and the standard deviation changed. But if you look at the actual shape of the distribution, that did not change. Multiplying a random variable by a constant does not change the shape. So we can see that we're going to we changed our x, we multiplied x by 150. It changed our mean and our standard deviation, but it did not change the shape. So it cost him $100 per trip, which means that his profit now is being subtracted by 100, but his probability stays the same. The cost minus the profit, how much he's collected minus the cost, is his profit. And then we see same distribution. But our mean and our standard deviation, again, does not change. Adding the same number, which could be negative, to each variable adds to A to the measure of the center and location, mean, median, mode, adds that number to the mean, median, quartiles or percentiles, does not change the shape, the spread, and does not change the shape. So if y is a plus bx is a linear transformation, well, the mean will change by a plus b times the previous mean. The standard deviation will change by the absolute value of the whatever is being multiplied. Linear transformations have similar effects on other measures of center or location. Whether we're dealing with the data or the random variables, the effects of the linear transformation are the same. These results apply to both discrete and continuous random variables. So combining random variables, many interesting statistic problems require us to examine two or more random variables. So x and y, define t equals x plus y. What does that do to the mean and the variance? So if you have passengers of x, 2, 3, 4, 5, probability, we have the standard deviation of the mean and standard deviation of the x situation. Then we have the mean and standard deviation of the y situation. How many total passengers can they expect in the random day. So you have the mean of 3.75 and the mean of 3.10. So the combined means is going to be our mean of the total. How much variability will there be? Well, if the variability is the only way to determine the probability of any value of t is if x and y are independent. Probability of models often assume independence when the random variables describe outcomes. You should always ask whether the assumption of independence seems reasonable. So when you're writing up your explanations, you should make a statement about whether the assumption of independence seems reasonable. In our investigation, it is reasonable to assume that X and Y are independent since the siblings operate their tours in different parts of the country. So that would be the sentence you would use to basically prove that there is independent random variables. If you do not put this sentence into your answer when you're doing these type of problems, you will not get the full points. So we are going to let t equal x plus y, all the probabilities combined. So t is 2 plus 2 is 4. Probability of p of I is 1.15 times 0.3. So we get, that's the probability of the combined. We multiply the probabilities, we add the x's, x and y. So the mean is the combined means. Standard deviation is at t minus the mean of the t times the p of the combined probabilities. The original standard deviation or variance of the x was 1.1875. The probability of the variance of the y was 0.89. So what do we notice? We notice that the variances of two independent random variables is also the sum of the variances of those two situations. Remember that you can add the variances only if the two random variables are independent, and that you should never add the standard deviations, only variances. Okay, we can perform a similar investigation and determine what happens when we define random variable as difference of two random variables. So the expected value D is the mean of D, or the mean of the differences between them, the differences of the two. The order of subtraction is important, so be very careful with that. The variance of difference of them is still the adding them together. So that's very important. Okay, combining normal random variables. If a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities. Any sum or difference of an independent normal random variables is also normally distributed. So Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in his randomly selected packet follows the normal distribution. That means it's a bell-shaped curve. That's what normal distribution means. With mean of 2.17 Gs and standard deviation of 0.008 Gs. If Mr. Farm selects 4 random packets of random, what's the probability his tea will taste right? So let X be the amount of sugar in the randomly selected packet. So each packet is an X. We find the probability, we're trying to find if the probability is between 8.5 and 9. So the probability of the first one is 2.1, or the mean of the first one is 2.17. The mean of the second one, also 2.17, because they're all normally distributed in the same way. So we add them all up and we get 8.68. We find the standard deviation is 0.08, but to find the variance, we have to square them. So we first square them and then add them up. We get 0.0256, and then we take the square root of that to figure out the standard deviation of the total. It's 0.16. So using our Z formula, Z of x 8.5 minus the mean over the standard deviation, we get negative 1.13. and 9 minus 8.68 over 0.16, we get 2.0. This part of the assignment we have not done yet. This is something that is actually from the next section that we would look at. But basically, if you drew a bell-shaped curve, 8.5 is going to end up being past the 1 cent. Just if you, I'm sorry, 8.68 is the mean, so it's the center. Minus 0.16 gets you to 8.52, so 8.5 is just a little below that. And then 9.0 is at the second standard deviation. That gives you 85% of the graph that his tea will taste right. So we will actually be doing many more problems like that last example over the next several weeks.